Welcome to this explainer. If you've ever found yourself just staring at a massive, messy block of repetitive spaghetti code, felt a headache coming on, and maybe even questioned your life choices, well, you are in the exact right place. Today, we're going to cure that headache by building your knowledge of Python functions from the ground up. By the end of our time together, you're going to know exactly how to write cleaner, faster, and much more efficient code.
Here's our roadmap for today. We'll cover the core of Python functions, handling inputs and outputs, adding ultimate flexibility, and finally, the one-liner Lambda shortcut. Now take a look at this. This is kind of your ultimate blueprint for mastering Python functions. By the time we wrap up this explainer, every single block, arrow, and concept you see here is going to make perfect sense. All right, let's jump right into section 1, the core of Python functions, defining and calling the basics.
First things first, what actually is a function? Well, at its core, it's a small, reusable block of code. But here's the kicker, the absolutely crucial part. It's created, but it's not executed until you explicitly call it. It literally just sits there, completely idle in your code, waiting for you to turn the key. It's kind of like a blender sitting on your kitchen counter, right? It's fully built, it's ready to go, but it's not going to do a single thing until you actually walk over and push the button.
So here is the exact step-by-step flow of how Python processes these little machines. First, you define the function. Second, you call the function. Third, the program executes the code inside. And fourth, you have an optional return step. It's a beautifully simple pipeline, honestly. Let's see what that looks like in actual code. Okay, step 1. To build this machine, we use the def keyword, which is just short for define, to create our function, and we're naming it greet. Inside it, nicely indented, we tell it to print hello. Now remember what we said earlier. Right now, we are just creating the machine. We aren't running it yet. Python basically reads this and says, okay, cool, I know what greet means now. I'll just save those instructions for later. And then step 2 is where the magic actually happens. We call the function by its exact name, followed by parentheses. Typing out greet with those parentheses is literally the equivalent of pushing that button on the blender. It executes the hidden code and bam, produces our hello output on the screen. The real beauty of this, you can call this function 100 times throughout your program without ever having to write that print statement 100 times. Moving on to section 2, handling inputs and outputs, parameters and returns. Now let's actually feed some raw materials into our machines. If we put a variable, let's call it name, inside those parentheses when we first define the function, we're basically creating a slot to pass specific information directly into it. So when we call greet and pass it Pranjal, the function dynamically swaps in that specific name and spits out, hi Pranjal. Drop in Sarah and it says, hi Sarah. It instantly adapts to whatever data you hand it. But what if we want our function to talk back to us instead of just printing text to a screen? Enter the return statement. Here we've got a function called add with 2 parameters, a and b. Inside, we're telling it to return a plus b. So when we call it with 5 and 3, the function calculates the math and literally hands us back an 8. And we can capture that 8 by saving it right into a variable named result. I really want to emphasize this point because it trips up a ton of beginners. Returning a value is fundamentally different than just printing it. A print statement, that just displays text for our human eyes to read. But a return statement actually gives you a finished, tangible piece of data, something you can safely store inside a variable and use later. It's what allows your functions to do complex math and then pass those answers right back into the main workflow of your program. All right, section 3, adding ultimate flexibility, default and variable arguments. Check this out. If a function expects a parameter, but you accidentally leave it blank when calling it, Python's going to throw an error and completely crash your script. Not good. But a default parameter smartly uses a fallback value to act as a brilliant safety net. By defining our function with the name equaling user, if we just space out and forget to provide a name, calling it falls back to safely outputting user. And if we do provide a name like Amit, it just overrides the default and says Amit. Now, what if you don't even know how much data you're going to be processing ahead of time? That's where args comes in. Using that little asterisk accepts absolutely any number of arguments you throw at it. Look at these examples. Calling total with 1, 2, and 3 effortlessly gives us 6, but giving it 10, 20, 30, and 40 outputs 100. Your function becomes infinitely flexible. It just scales up or down to handle whatever you throw at it in that exact moment. And finally, Section 4, the one-liner Lambda shortcut, quick and simple anonymous functions.
Take a look at this incredibly minimal Lambda syntax. Notice anything missing there? Yeah, it drops the def keyword entirely. This creates a small, anonymous function that is perfectly suited for quick, simple math, like squaring a number. When we call this with a 5, it instantly takes 5, multiplies it by 5, and boom, outputs 25.
I like to think of Lambda functions as tiny little rockets for your code. They're meant to be incredibly fast, highly efficient, and take up literally a single line of space. Now, you wouldn't use them for complex logic, obviously, but when you just need a quick throwaway function for a hot second, Lambda is absolutely your best friend. As we wrap up this explainer, I want you to burn these 3 best practices into your brain. 1. Define once. 2. Call many times. 3. Reuse everywhere. This is exactly how you guarantee that you're coding smart. Don't write the same logic twice. Honestly, if you ever find yourself copying and pasting chunks of code, just stop. Stop immediately. That's your cue that it's time to build a function instead. There's a great saying that perfectly captures the whole philosophy of writing modular code. Small functions, big impact. Great programming isn't about writing these massive, unreadable monolithic scripts. It's about breaking incredibly complex problems down into small, manageable, and reusable pieces. Those small functions truly do have a huge impact on your workflow. So, I want to leave you with a question to ponder today. What repetitive code will you turn into a function today? Seriously, take a look at your current projects right now. Find that messy spaghetti code and ask yourself how you can build a clean, efficient mini machine to fix it. Get out there, start optimizing your scripts, and experience the power of Python functions for yourself. Thanks so much for joining me on this explainer, and happy coding.